All right, everybody, here is another example. We are graphing the transformation of a parent function, and the parent function that we are looking at now is 1 over x squared, which we like to refer to as the volcano. And what does the volcano look like, you might ask? I'm glad you asked. Here we go. Now, the only points we give a hoot about are, come here. Okay. This one, -1. Oh, I labeled that wrong. That's really annoying. That's +1 right there. Am I like really gonna fix this right now while I'm recording? Or is that like too much right now? Because that would be... I can't help myself because it's wrong. I'm sorry, guys. Fixing new grab an image. Sorry. Oops. I cut too much of the graph. Oops. Okay, whatever. I'll just pull it on like this. Okay. Sorry for the delay. Don't be mad. But I had to fix it. Okay. Like that never happened. Don't tell anyone. Okay. Now. The only points I care about on an assessment for you to really plot are the -1, 1 and the 1, 1. That's really going left or right 1 over b, and then up and down a, right? Depending, which way, if a is positive or negative. I just plotted the over a half of 4, as you might remember in the last example, where we were just dealing with 1 over x, right? Not that graph, wrong one. JK. This one. When we plugged in 2, we got 1/2, and when we plugged in 1/2, we got 2, right? But now, when we plug in 2, we get a 4th, smaller. And when we plug in a half, we get 4, bigger. So it's just more extreme on its approach to going up or going down, right? So it's a closer curve to the asymptotes. Like, look at the shape, okay? The curve is getting closer to those asymptotes quicker. So just know that when you draw the volcano, that it kind of looks like that. You know what I'm saying? So the only points, like I said, I care about are 1, 1, and -1, -1. So we will see that in this example. So let's get rid of those things. Okay, so we have 1 over x squared, and then, okay, clearly list all transformations. So what are they? Well, we're going to the left 5, and we're going up 1. Then we have a vertical stretch. That's your a value in the numerator, right? We have a vertical stretch of 3. Okay? So these are my transformations. So I'm going to take that little volcano guy and get everything over there. So my asymptotes, left 5, 1, 2, 3, 4, 5. Left 5 and up. Okay, there's your little asymptotes. Like before, we can actually write the equations like I did in that last example. So here you have a vertical asymptote at x equals -5, and we have a horizontal asymptote at y equals 1. All right. Now, the only points I care about, like I said, are those 2 main points for this graph, because otherwise it's just too messy. And that's got a vertical stretch of 3. So instead of going 1 and 1 like that, okay, we're going to go over 1 and up 3, and over 1 and up 3. There you go. Now, if you had to think about it a little bit, like if I plugged 3 or plugged 2 into 1 over x squared, we saw we got 1/4 before. So it would really be 2 over times 3. So 1/4 times 3 is 3/4. So it's like right up here and right about up there, and so on and so forth. But it's very, very quickly rising and very quickly getting really close to the asymptotes. But I don't care about anyone except these guys. These are the money points right here. Boom. All right. Beautiful. Best thing you graphed your whole life. Is it not? So your domain from left to right, it's negative infinity until -5. That's the first break and interruption in our domain. That also domain comes from that denominator, right? X can't equal that number right there in the denominator. What are we doing? There we go, a little neater. And then -5 until infinity. So that was from left to right. And then the range, unlike the other one, the range is from negative, not infinity, negative, not negative, positive 1, because that's where my horizontal asymptote is, not a parenthesis, hello, comma, infinity, up forever. And then are there any extrema? There's no point. If you look, we are going up and down, but there's no point at which that change happens. So we don't have that maximum point. So NA, NA, we don't have it. That's it. Looks like a cutie little volcano. And there you go. Oh, and the little tip to remember. 1 over x, right? Actually, that's, hold on. Okay, down here. Last little gem, right? Okay. If you're dealing with y equals x, right? That passes through these two quadrants, right? Similarly, y equals 1 over x, right? Is going to also be in those two quadrants, right? So there's that bit of similarity. It's in quadrants 1 and 3. Also, the way this cuts through ends up on the other side of the x-axis. So do our branches, arrows, as when it comes to the asymptote, they point in opposite directions. So opposite side of the x-axis, opposite directions against the asymptote when you have an odd power like x to the first on top or on bottom. And then similarly, we have y equals x squared, right? Versus y equals 1 over x squared, okay? So what is that showing me? Y equals x squared, I bounce off of the x-axis. I'm in quadrants 1 and 2, and I stay on the same side of the x-axis. And then my 1 over x squared is going to look a little bit like this. And again, against that asymptote, I'm in quadrants 1 and 2 again, but against that asymptote, I'm pointing in the same direction. Up and up is my asymptote behavior. Up and up is my end behavior, right? Up and up, asymptote behavior. That came from the x squared on bottom. Up and up, end behavior, that came from the x squared in the numerator. Versus here, end behavior, down and up, that's my end behavior for y equals x when it's in the numerator. But y equals 1 over x, down and up, is my asymptote behavior. Keep that in mind. You're welcome for that. That is music to your ears, math music. So hope you enjoyed these videos. They really threw a wrench in the mix with everything. I'm sorry it's a little scrambled. There's a ton of videos on that playlist that this is on. So you have tons of things to practice, and I am going to finish editing and post the quizzy now, but it's like an unlimited attempt flashcard thing, so don't wait till after a test to do it before the test for sure, but you have unlimited attempts and you'll have enough time to do it. It's just to help you practice matching. Okay, love you, bye. Where's Dallas? This guy, why does he sleep and he wakes me up at like 4 in the morning? He's like, let's go for a walk, Mom. It's time. It's morning. Bye.